Hello. Hello. Um, Today I prepared my session for the how we handle and detect our deadlock, circular deadlock condition. So there is new agenda. In historically, there is some lock detection engine as a debugging feature in the Linux kernel. We called Lockdep, but there there is some limitation for the Lockdep support for some circumstation. So Byungchul uh, introduced a depth as a new debugging feature for the weight and lock detector for the Linux kernel. So uh, we can utilize this feature, but this time now depth not supported in upstream kernel, but we focused on support for the upstream Linux kernel. So we continuously rebase and enhance the depth engine for the weight and lock detection. So I will continue to some introduction for the depth. Uh, and I'm currently preparing some BOF session for the DevConf. So, right, uh, we can see the two contexts here, X and Y, right? X and Y, right? Lock A hold in this code, and lock B hold in this code, right? And the context are proceed, right? And context X want to hold lock B in this in this code, but as you know, context Y previously hold the lock B, right? And also context Y want to hold the lock A, but lock A previously holded by the context X. So we cannot unlock this lock A and lock B, right? So lock A and lock B are never go to this end of this point in this slide. So we called this situation as ABBA deadlock, right? So, oh, sorry. I want to see my settings. So I need to, I I need I need to uh, present in this state because I want to see my chat, right? There is uh, some context that we need to understand, right? So I need to chat each other. There's two people, right? So we called this situation as ABBA deadlock. So this occurred during the runtime, right? So we need to runtime checker for checking rock order for the deadlock when they actually happens, right? And this is important before a deadlock actually happens, right? So as I said, there is some long history for the detecting on the runtime for the lock dependency. We called this as Lockdep. These Lockdep features are written by Ingo Mola, and as you can see, when the lock A are hold, and while holding the lock A, this context want to hold the lock B. So these situations called as A depend on B, right? So we draw the arrow as a dependency for from A to B. So next slide. So as you can previous slide, as you can see, this situation are drawn as from A to B. So Lockdep debugging feature on the Linux kernel making a build dependency graph from A to B. And context Y as perspective of hold the B, and context A Y next want to hold lock A, right? So as you can see, from B to A, they make build dependency graph. So as you can see, this is the deadlock, right? So A B B A deadlock, and this makes some circular dependency, and code never go to after the ABB deadlock point, right? So if you some want to ask something, write in chat, and I know that there is some Korean people, so if you type in the chat as a Korean, I translate as an English, so other people understanding what they mean. So feel free to asking me. So wow, there's so many dependency in global space, right? This is the situation that what we're learning the Linux system, right? There is so many process and so many context in here, so there's so many dependency. So at that time, there is no dependency from this time, but right. if there's is there kind is there any kind of specific data structure that describes this kind of dependency graph? Right. As you know, this is some this dependency are implemented by Lockdep engine, right? So they search and make some this complex graph data structure in their inner their engine, so they can detect this deadlock situation, right? So if you want to more detail for the how they make their data structure for the graph, we need to investigate how Lockdep are implemented. So, but there is a good starting point. Lockdep is very big and very long time history, but depth is short, right? So if you want to investigate how they work in inner data structure perspective, you can investigate the depth code. Depth code is not wrong. So, right, we can focus it from how depth are working, right? So, and plus depth is more advanced, right? I think a good starting point, some looking at the depth code. So, are you planning to look into the party? No, this session is focused on some how depth are uh, uh, how depth are working, and some I think some broad eye view of how depth are working, and depth is another uh, another how they say another concept, the comparison of uh, rock depth. So I will focus on what is the different and what is making the how they depth are more advanced, right? I think this is the key concept. And Bemcher said, if you want to investigate the code, you need to 100% understand in this content, right? So I will keep going on, right? I hope to answer to LSG, right? Right. If you understand what it means, I think there is some point for what is the different lock depth and depth. So we need to understand that point, very subtle point, and this makes some great, huge difference, right? So, right, I explained there's new dependencies are here, and this makes some circular dependency from Y to Q to da, 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 right? So, rock that, repeat, right? So, this is some complex context in here, a three context, and everyone you need to remember different between spin lock and mutex, right? In when the spin lock when the context enter the spin lock context for the critical section, right? Spin lock is video lock, and that context never sleep in the spin lock critical section, right? So there is some mutex, right? In the mutex context, for the perspective of critical section, they can sleep, right? So there is some way, right? This is the key point for this session. So keep remembering, right? Way. So we can see the context X and context Y, context G, and some Y side, right? Y side are time that code be code be executed, right? So this is the upper side in here. So context Y hold the lock C, right? And there is some mini gap, but context X executed and hold the lock A, and context Z hold the lock C, right? This is the some time domain in the context in here. So, and context Y want to holding the lock A, but as you know, context X are previously holding the lock A, right? So context Y waiting in here for want to hold the lock A. And next, context X want to some event for the B, right? So we need to focus on this is the not lock, right? This is the waiting that want to some event are occurring from another context. So, right? So event B will be occurred in here, context Z, right? So as you can see, there is some headache for this context. You can assume that this is the deadlock, right? Because this is the deadlock presentation, right? So you can think about it. Why is deadlock in here? I will give you some 5 seconds. 5, 4, 3, 2, 1. Right. In this time, right? This part is the Lockdep, right? Lockdep. So I will review the some deadlock point in the previous slide, from later slide, but we keep remember the Lockdep's concept, right? Lockdep build a dependency. When they hold the lock A and want to holding the B, they build a lock dependency from A to B. So we can review this slide. So I can explain why this is the deadlock situation. So, right, they holding the lock it from the each context, and context Y want to holding the lock A, right? And context X holding the lock A. So they are waiting in context Y. And so context B, context X want to some event occurring from another context, and context Z want to holding the mutex C, right? But context Y already holding the lock C. So context D never end, right? Never end. They want to holding the lock C, but context Y already hold the lock C. And context Y want to holding the lock A, but context X already hold the lock A, right? So if you have a question for this situation, feel free to asking me. So context G cannot go to the code execution, the code. Right? You can almost understand, right? Context G, some point in slide, they execution, some waiting for the want to holding the lock C, right? These code are executed, right? As you know, mutex or some lock functions, if lock are hold it, they are waiting, right? And if there anyone hold the lock, they can hold the lock from their context, and they execution their critical section code, right? So context G, in your question kind of confusing for me. If this situation is like context G is not even starting, context G are started, but they are waiting, right? Right? Do you understand what I mean? What I said? They are started, but they are waiting. They want to hold the lock C, right? Good, great question. Right. Oh, it's simply waiting for getting lock C. I think description will be much better if you show process state diagram together. Right. Great comment. Thank you. So, right. If their enhancement for this slide, we can, as you said, right, there is some state from here. So I think emoji is good for them. So right, you write smile emoji in chat, right? there, I think there's some circle in eye emojis are good for this state, right? And this state also good. And I think some emoji that waiting time for the event are good for emoji for the process state. Great suggestion, thank you. So this is the deadlock situation. Great. But this is the important point for the Lockdep. Lockdep will not report this situation as deadlock. So if you config on Lockdep and something like situation in this slide are occurred, they not report it. Lockdep, they have no feature for the detecting this waiting. They only can detect each lock, right? This is the important why Byungchul are implementing new deadlock detection system for the Linux kernel, right? This is the important point, right? So in perspective of Lockdep, they can make some build dependency from this side, right? For the mutex lock. So context Y, hold C, lock C, and he wants to hold the lock A, right? So this makes from C to A arrow for this point, right? But deadlock situation are occurred, but so there is no report in the kernel log, but kernel are deadlocked, and this will be hung task for the kernel. So this is hard to find how they are deadlocked in this situation. There's no report, and we need to find and investigate all the process they are stuck and find the dependency for the each lock, what the making some circular dependency for that system, right? So this is very hard because in real system there's so many dependency in here, right? So in perspective of some global system, this is some simple example, but hard to understand. When I first saw this, I need to thinking a, a few minutes, like SGL, right? But I understood context G never go to this code after this code because context Y holding the lock C, so they are waiting, want to holding the lock C, and context Y they want to holding the lock A, but they never go to next step because context X previously hold the lock A, and context X they want to get an event from the another context, but context Z are never ended from this point, so this event never happened, right? So context X are never ended for the waiting at this point, right? Wait can cause a deadlock, right? And I will keep remember for folks. So how does the Linux kernel try to handle this entangled dependency situation? I think how program disentangle this situation, well, maybe answer would be just terminating process is also important. As you can see, this is the kernel space situation. So we called this as a bug, or if user making this situation as some malicious something like that, we call the vulnerability for the Linux kernel. So this is the bug, and this is fully tested by kernel developer, right? So as you can see, before a deadlock actually happens, right, we need to detect and fix it. This is the bug. AI can never handle this complex situation when they learn time, right? So this needs human. This needs a smart human, right? Right. And AI are running on that system, right? AI can never patch or something like that when they learn time, right? So great news for the kernel developer, right? AI can't quit the kernel developer's job when the runtime deadlock are occurred, right? This is the kernel developer must fixing point, right? So wait can cause a deadlock. This is the important point. So this is the term for the debt that written by the Byung-Chul. So Byung-Chul defined a new concept for the detecting some circular dependency for the Linux kernel. There is a context that executing the code, as you know. So there is waiter, right? Waiter want to occurring some event B from another context, right? And A event A occurred after the event B occurred. So event A occurrence depends on event B occurrence. So we redefined the concept. When event A occurrence depends on event B occurrence, we draw some dependency graph from A to B, right? So if event B occurred from this point, event A can occur, right? So we need to redefine them. right? We need to catch not only lock, but also wait. So depth are defined that want to holding some lock. This is the situation that waiting, right? So event A occurrence depends on B. We draw the dependency graph from A to B. A depends on B, right? So this is the first situation that we previously saw. So this is the definition from the Lockdep. Hold A, hold B, right? So context Y want to hold A, but they are holded by the context X and each other. So A, B, B, A, deadlock. But we redefined this concept. So we are not focusing on the holding a lock A. We focused on some waiting for the event. So we redefined from this comment, right? So we don't need to focusing on this context, but who want to hold the lock B, this go to the waiting for the event. We redefined unlock as an event, right? So context X want to event that unlock B, right? So we assume the unlock as an event B, right? So this context want to some occurring for event B, and as you know, context Y also want to occurring event A. That event A unlock the A, right? This is the core concept of the depth. So as you know, event B are never occurred, and event A also never occurred, right? And in perspective of drawing some dependency graph, A are depended from event B. Event A depended on event B. So we draw from A to B and build dependency graph in here. Is it like just newly defining term waiting for more comprehensive context, including lock? Right. Forget about lock, right? Waiting is the very important point for the depth and some new generation for detecting the runtime circular dependency, right? I've been researching for the some deadlock detection system. For there is some paper, not only some distribution system, but also some old 80s some paper that some OS, but I'm not found some this sophisticated concept definition for the deadlock dependency, deadlock detection. So I asked the bencher, would you make some paper for this concept. So if there's time for writing a paper, he wanted to submit the some well-known some conference, something like that. So, right, I think there's some, as you know, there's some conference, Usenix or some security conference for the CS division. So, right. So I continue to explain. So context Y, as you know, right? This need to fix. Right? This is not important. So as you know from previous slide, context Y, in context Y, event B occurred depend on event A that unlocked in this situation, right? So we can draw a graph from B to A. So this makes some deadlock, A deadlock, right? And replicate it from depth, right? As you know, this is the situation that Lockdep will never detect in this context. So we need to redefine in perspective of a waiter and event, right? So want to holding the lock is waiter, right? So there is some waiter in this and in this and also in this. And right there is event for the waiter. We defined unlock as event A, and for the C, lock C for the event C and event B, right? So we can redraw from the redefining from the dependency. So event A depends on B, right? And the event B is the waiting event, right? Lockdep have uh, no way to find this waiting. So we can draw the dependency graph from A to B. Event A are depend on occurring from the event B, right? So in the context Y, event C depend on event A. Event A is in here, right? So we can draw from C to A. And also, context Z, we can draw a dependency graph. Event B depend on event C, right? Event C are in here, right? Current system lock depth, catch circular dependencies related to lock, right? Holding the lock and right in this context, right? Holding the lock is the key point for the lock depth, right? Right. Core concept. Thank you for the summarize. And 2 is the in point 2 is the main point that want to holding, we assume this as a waiting, right? And as you know, waiting, we focused on waiting and occurring event, right? So we can detect for that. So so I some imagine the situation that some when they want to holding the some fork from the, as you know, there's some example that some the men are keeping the fork and they want to eat, but there's some deadlock situation, right? But if there's someone have a stomach and want to go to toilet to doing some pooing, so this also some waiting also makes some deadlock context, right? But there is no research for that from previous research for the some computer science. So if there was some research for that, uh, 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 I want to know that and reporting me. I appreciate for it, right? So this makes some circular dependency, and this makes, as you know, this is the deadlock. So that can detect deadlock, right? So this is the global system that learning the Linux, that there is so many new event are occurred in here, but if the circular dependency for the ng, this can report from the depth feature. So I will summarize that how we can analyze the depth report. So when the waiter before they go to the waiting, from this point they request event for the other context, right? So they request A for the context 2. So context 2 start event context of A, right? And context 1 are waiting for the occurring of the event A. And context 2 triggers event A. So if they are waiting for this B, right? So as you know, we defined, we can in depth we can draw some dependency graph. If a event are occurring dependent on event B, we can draw the event A from A to B, right? So this is some summation, right? S and waiting. We can this event waiting for the B are waiting, and event A are E. So we can define in the in real report for the depth that S are they send some S, but this is not focused on. This is not important. We need to focus on the E and W. So because we need to focused on the dependency, right? So if context X, right? If, all right. Context are waiting for the occurring event B, and event A are depend for the occurring for the event B. We can draw, as I said, from A to B, right? So event A occurrence depends on event B occurrence, right? So this is the real some detection from the depth findings. This deadlock cannot be detected by the Lockdep, right? So because I will share this link from the into the description after this session, but in this point are important, right? Deadlocked are tri-lock. This is the waiter, not the lock. So this is the important point. So Lockdep are not draw a dependency graph for the waiter. They focused on lock, not the waiting context, right? So this folio tri-lock, there is some waiting for the event. This is not the lock, right? So, right. But depth are we define how they can find the lock, deadlock situation from the circular dependency. So we can find the deadlock situation for the wait bit, right? Deadlock. This is the wait for the some event, right? So this is the mail from the Linus Torvalds. So Linus Torvalds asked to Byung-Chul. So Lockdep, there's limitation for their implementation. So I think that can report it. So Byung-Chul, please testing about it, and some other member from the mailing list found the deadlock situation for that. So he reproduced it and reporting it, and this is the real bug in the Linux kernel, right? So this is the way. This is from the waiter, right? This bug from the some deadlock from the some waiter in this context, right? So someone reproduced it from the Igalia, and he found that, and this is some something that Lockdep have to improve something improvement for this context. It seems Lockdep depends on predefined annotation about text, right? I'm curious how that handle if it doesn't rely on annotated symbol. Depth also need to annotation, right? Good question. Good. Great question. But Lockdep have limitation for the waiter, right? So, but the dept had some concept that redefine some Deadlock condition. So dept also, dept will also find Deadlock situation if there are some waiter from the context and making some dependency from that context each other, right? So adding the annotation is easy, right? There is so many annotation are implemented by the Lockdep. So dept can utilize that point that some almost 20 years adding. I'm looking forward your review about dept implementation to the code review. Great. If there's some time after the my conference, DebConf25, I will investigate dept implementation and I will review the internal code of the dept, right? So I can skip this situation, but right, Lockdep people add this handling for this, and right, great, thank you. So as you know, general weight are making some dependency from the redefinition from the dept, right? So at previous mailing list slide, right, there's a waiting, right? And there's some API, like some DMA fence. This is the null, right? This is the waiting some and want to occurring some event, right? And right, thank you are seeing the future, right? Annotating waiting event, right? And we can utilize Lockdep's annotation from the lock context, right? So we can add these things, right? From the right, good. And this is the another point that benefit from the redefinition, definitioning by the dept. I need to explain what is the RW locks, right? So, folks, you need to some great advantage for the RW locks, right? RW locks, there's a read lock and write lock, right? But when the read locks, if there are some other read locks for that lock something, they can not not want to holding the lock, right? They can read it, the critical section. But if there are writer for the context and they hold the lock, they need to reading. So if there are some context that locking the read, some other context want to some only read some context, the critical section for only the read lock, they can read the lock. So this is the great advantage for the RW lock. And writer, right, if there's critical section that protected by the write lock, writers need to waiting for the ended all the read lock and write lock, right? So there would be some great advantage for the read context, right? So if there are some workload that only the reading in the critical section, they can get advantage from this, right? This is the great point of the RW lock, right? So we can simply define in this situation, right? So read lock, and there is read lock, and right. So read lock B only waiting for the right unlock B, right? So we don't care about the read lock B, read unlock B, right? So this care about the right unlock, right? Right. And in this situation, the unlock A event A. So event A depends on the right unlock from the B, right? So we can draw from event A depend on occurring right unlock from the B, right? And right B is care the two case, read unlock and write unlock, right? So we can draw this situation at 2 point. If there are some event that read unlock and write unlock, this depends on A depends on these two events, so we can draw this diagram. So we care about only the event, wait and event, right? And right. And if someone using the Lockdep, there is some very sad point. Very sad, right? Very sad, right? I suffered from this when I thought, right? If there's some manual time, right? You can assume my experience. I want to pause it, and I run it when I before the sleep, and I awake the morning. There is one case only that Lockdep always reporting for one case, right? And they never report after that, right? So right, Lockdep only one report it, right? This because from the Lockdep's internal their implementations limitation, right? They only one reporting it, right? But that reporting are morely not false positive, right? Almost there is some issue, right? This makes some horrible, we call the nogada, right? In Korea, there is some some harsh coding things that if there is no way to we can off that situation, we turn off the config for the Lockdep, or we need to some remove or making on unconfig that the whole subsystem, right? If you want some real report, But if this occurred from the another system, what would be the case for the false positive? Simple example might be helpful for understanding, right? I need to some example for what you're saying, and I heard that some people that suffered from the Lockdep, they don't believe the Lockdep's reporting. Uh, in 10 years from uh, in 10 years ago, there's a Lockdep have many report for the false positive for so many kernel developer are annotating it and enhance things in that, and they have mostly they not report as false positive, and I think we can find easily for the searching the mailing list for the false positive for the Lockdep. So I will share it after this meeting. So this is the harsh job, right? This is right. Debt are not reporting once. They continuously reporting. So if there are circumstances that deadlock from the MPU when I using the some AI things, right? Connor making some log of issue, so we can find some report from the Connor log from the debt, right? We can easily find it, right? Debt are mostly reporting it, right? Right. So I think this is the important point for the case, because if there's some reporting from the Lockdep in the booting sequence from the corner, we cannot find the real use case for the log in the MPU when we using MPU. Lockdep is like putting breakpoint at false true positive deadlock point. Right. Right. So we can add some ignore the oops or something like that. Corner will be execution, their state, but I think when we found some bug in the Linux kernel, we can usually some oops on panic for the point. So you can see the situation that kernel always rebooting for the Lockdep reporting for that. It is not good, right? If there is some booting point and that are not the real case for the deadlock, right? This is sad, right? This wasting wasting the time and my some fee, electricity fee, right? Forging is very consume the electricity for the my computer, right? So right, false positive need to some enhancement for the debt, right? But that are not stop the reporting, and they continuously reporting the some circular dependency, right? So we can review from the question, right? So if you someone want to some lower percent of the false positive using Lockdep, your choice, right? But the lockup is occurred that from the very complex situation that include some wait and want to event using dept, right? And this is some reference that how Lockdep are holding the RW locks. So they focused on the purely lock, right? So there's so many code, right? There's so many case. Some catch the RW locks, some dependency, right? So I heard this is some very long uh, working time for they handle these things, right? So many maintainers are working on this, and right, I heard it about about some year for uh, finding the RW lock dependency for the lockdep, right? There's so many situations, right? So um, um, I want to uh, someone wants to using and hope to finding some hints and some good point for that. So I will share some right. This branch there is some code in here, right? So these are rebased from the recent latest release 6.154 for the kernel, right? So you can use it. And there's some working from Byungchul. And last comment is from me, right? So I hope to many people who suffered from the lockup situation. So, right. Today's sessions are end, and if you someone want to asking me for the question, feel free to ask it from the comment or the my community board. So thank you for the watching this streaming. I hope everyone have a great weekend for this week. Goodbye.